Guys all for coming. Welcome to our very first Micromouse lecture. It's going to be on overview and power. Please scan the QR code if you haven't already. And I'm sorry about this. We'll get bigger rooms in the future. I know it's like really cramped.
Wait, did you make the form like anyone can view it?
Yeah. Unless are you not able to view it?
Yeah, but this has been happening for like every meeting I've been to like in the past like few weeks.
Okay.
So I don't know.
Wait, was anybody able to fill out the form?
So it can't be UCL email?
It can't. Some of them can't be UCLA. Have to be like UCLA authorized.
Wait, if you can't,
shit.
it's all right. It's just to gauge attendance.
Oh,
I
okay,
think.
okay.
So yeah, don't feel bad if you can't. But okay, we're gonna get started. Once again, welcome to our Micromouse program. Thank you guys all for coming. This year we had over 100 applications, but we can only take 75. So really good that you guys are able to come out and stuff. We're very excited to have you guys, and we're looking forward to working with every single one of you guys. Okay. If you don't know already, we are your leads. My name's Nathan. I'm a third-year electrical engineering major. I like playing basketball and volleyball, so hit me up if you want to play. And
I'm Michael. I'm a second-year CSE major, and I'm a gamer. But also, I want to preface that we're sorry about the room. Like, I don't know, we submitted, or he submitted, I didn't submit it. He submitted like the room requesting like early, and then also like our like person that actually like requests the rooms from our room request submitted it early, but like they're so slow, so like they've just given like horrible rooms and stuff, and so like, and we didn't even get this till like a week ago, even though we submitted it before. So like, hopefully in the future it's not like this, because usually it's not like this. Usually we have like a big room which can accommodate more than the amount that we have.
yeah. And don't worry, this lecture is pretty short. It's just our first one. Just kind of like to bring you guys into Micromouse.
Yeah, that's our bad.
Yeah, okay.
Hey, the videos are on YouTube though.
Yeah.
Yeah. Okay, so here's some details and some logistics. So, like the email that we sent out, Micromouse does require a deposit of $50, which you can send to UCLA IEEE on Venmo. But the main important thing is that this deposit actually gets returned back to you as you complete the Micromouse program. So it should be free if you guys all finish. Okay.
Can I send it through Zelle?
Yeah, you could definitely send it through Zelle.
Okay.
You could talk to us after the meeting
Sure.
if you'd like. Yeah, and then like it has more specifics in the email that we sent out if you guys saw. And then our main form of communication for Micromouse this year, it'll be Discord. Same with IEEE in general, so please join our Discord. And then you guys can add yourself to the Micromouse role. And what this will give you is basically our general chat where we'll post like announcements, our lectures or assignments. And then we'll eventually also make like Teams chats. Like all of you guys will be placed into teams of, I'd say like 3 or 2. And then we'll make Teams chat for you guys on Discord where you guys can basically just reach out to Michael and I if you guys have any problems. And you guys can ask for help there too. Okay.
Yeah. Also, wait, 2 things. The one, it's emphasis on 3 people, because like then we have to make way more things. People like pick 2, so you're gonna have 3 people in your group, except for like probably like 2 groups or 1 group.
Yeah, because we took a lot of people.
So yeah, we need the materials to be distributed well, and also, yeah, emphasis on joining Discord, because like I'm not gonna send emails, so if you don't see my messages on Discord, then you're cooked. So
yeah, everything's on Discord. Make sure you guys have it downloaded. Okay. All right. So for today's topics, it'll be really short. Don't worry. Afterwards, we have a social. You guys can meet each other, and then we got food too. So please pull up. And then, but for today's topics, we'll be going over an introduction and overview of Micromouse, where we'll cover the syllabus. And then we'll hop into our lecture where we'll discuss power, which is how we power our Micromouse and our boards. And this involves our batteries and voltage regulation. Afterwards, we'll go into our software. And for the software that we use KiCad, which is for schematic and PCB design. And then we use Cube IDE for how we program our RAT. Like this might seem like really confusing, like all the software, but it'll make sense. And then afterwards, we'll show you guys a live demo if you guys want to. It'll be pretty short. I know you guys are all pretty cramped in like standing, so okay. But for our goals this year, like to put it briefly, we hope every one of you guys is able to design, build, and program your own very Micromouse. And then at the end of the year, compete in the All-American Micromouse competition, which is held at UCLA. But most importantly, hopefully you guys have fun in this program and learn as much as you can. Yeah. Okay, and then for a year overview, during this fall quarter, you'll learn the basics of how to how the Micromouse actually works and the different subsystems that are part of it. And you'll build your rat. And what is the rat? Well, this fall quarter, we're gonna be giving you your own PCB that we designed. And then you're gonna be in charge of assembling your rat, which requires like soldering on components onto the PCB. And then you'll be programming it so that it can move like left, right, if it detects a wall, and you'll be like working with sensors and like the motors and how to control that. And then in the winter quarter, that's where you're gonna be implementing the maze solving algorithm so that you're actually able to solve the maze with your mouse. And during this winter quarter, you'll also design a PCB, which is like the coolest part, in my opinion, of this program, to have something tangible that you can take home. And then spring quarter, you'll put all that together and upgrade to a mouse, which is basically, instead of us giving you a PCB, you'll have your own PCB that you design, and you'll be doing the same stuff that you did fall quarter, like soldering on components and programming it, and implementing the maze solving algorithm. So at the end of the year, then you can compete in the All-American Micromouse competition. Yeah, okay. So this is the syllabus. Do you want to share it?
I opened up in another tab.
All right. I've been assigned to go over the syllabus with you guys. All right. Let's see. I only want to go over like some important parts of this, so I don't do it.
Yeah,
as long.
Most of it you guys already heard before, but we'll also post the syllabus in our Discord, so just make sure you guys have access to our Discord channel.
So I guess the important parts of this are the project overview parts right now, which is like, so in the first quarter, so this quarter, we're gonna design our rat, which is like the mouse we designed that we just like want you to build and program very like, what is this? Okay, whatever. We want you to like do it so that you can like get the fundamentals down. Let's see.
And then
in the following 2 quarters, yeah.
Go.
In winter, you're gonna like actually design the schematic and PCB of your own mouse, and then in spring, you're actually gonna put that all together and also do a lot more coding because the rat coding is very easy. All right, so we went over the teams. Yeah, around 25 teams. We play like 26 or something this time. All right.
Sorry.
I went over that. All right, I think we might have this later on the slide, but you should just do this, or you should note it now and do it as soon as you can, which is these trainings. So I think they're due like next week sometime, so you should do them soon. You need them like in order to do anything in our lab, which is basically like everything you'll do, so make sure you do that. Let's see. Yeah, you can come to the lectures. We'll record them and we'll post them on YouTube. But they're kind of ass on YouTube, so I would come, and then hopefully we have a bigger room next time. Let's see. You'll have assignments. In the first quarter, it's going to have an A assignment and a B assignment. The A assignments are like actually stuff that you're going to do for your rat, and then the B assignments are stuff you're going to do individually. So I guess also A assignments are like team-based, and B assignments you want to all individually do by yourself, and you don't have to do them in a lab as well. Okay, let's see. We mentioned it before, but you need to pay a $50 deposit through Venmo or some other means, and if it's through some other means, you need to come talk to us because we need to note what that means was and stuff like that, and your name and stuff like that. Yeah, and through Venmo, you don't, because you just like put your name and your project. Yeah. This drop policy, just do the assignments and you won't get dropped, is basically what it says.
Yeah, and if you're having a tough time like with
Yeah.
like the assignments, just let us know. Like we'll give extensions too.
Yeah.
This is just to help you guys like stay on pace so you guys don't fall behind.
We're very gracious, but like we don't want you to have not done any of the first quarter assignments and then you try to do the second quarter stuff. And it's like, you're not gonna be able to do that. All right, that seems like all of that. And now I'll go into some cooler stuff, which is batteries. And I didn't make these slides, so any jokes on here do not associate with me. All right, so I'm gonna go over like some types of batteries, just like, this is like some not so essential information, but still like useful to know. And like the more you know about your rat and your mouse, the less you'll be confused and stuff. So there's like many types of rechargeable batteries, but some that we have listed here are lead acid batteries, which were like some of the like first rechargeable batteries to ever like be, I don't know, designed or something. But I mean, as such, they have like some bad aspects, like that they're really heavy. So like they're just like, well, I mean, yeah, they're just really heavy. They're really cheap though, but the size and the weight makes it like not a good option for us. So we're not gonna be using that. Then there's these nickel metal hydride batteries. They're basically like used mostly as substitutes for like alkaline batteries, like, you know, like the AA batteries that aren't rechargeable that you put in like your remotes and stuff. But they're kind of bad because like they have comparatively low like cell voltage, and we want more cell voltage, so we're not going to use those either. And then this is the third option, and by process of elimination, you could deduce we're going to use these, but we're going to be using lithium polymer batteries to be specific, but lithium ion, lithium polymer are like, they're more expensive, but they're very energy dense, so we'll get a lot more, they'll last a lot longer, and they'll be able to provide a much stronger voltage than like the nickel metal hydride ones and the lead acid ones. Oh yeah, they're dense, so like they won't be as heavy as the lead acid ones. All right, so these are our batteries, which are lithium polymer, which is like, I mean, it's not important, but the distinction between lithium ion and polymer is like pretty loose. Lithium ion is like more of like a liquidy ion substrate, which like is used to generate like the power and stuff. Whereas the lithium polymer is more of like a gel-like polymer substance. And they have trade-offs and stuff, but overall we're gonna use these, I think probably because they're cheaper than lithium ion. So our batteries have a capacity of 1200 milliamp hours, so it's, I guess actually let me preface, if you guys don't know anything about any sort of electrical units, you could think of volts as like, actually a good comparison people usually use is like with water in pipes and stuff. So volts is like the pressure which you're applying to your pipe system, and amp or amperes are like the actual amount of water flowing through the pipes and stuff like that. And they're related and stuff, so if you want to push more water through the pipes, you're going to have greater pressure and stuff like that. So you'll have greater voltage for greater current, which is measured in amperes. And then the max continuous discharge of our batteries is 1 amp, and the nominal voltage is 3.7 volts. And we're going to use 2 because our motors require 6 volts.
And then this is what it looks like. So like, you stack 2 batteries on it, and then it's able to function.
Yeah. All right. Did you replace that GIF?
Huh? No, you have to press it, I think.
Okay. Why is my battery on fire?
So this is what happens when you like overcharge a battery, and then like, at least these ones in particular.
Yeah, this is one fail mode for a battery, but that was just like a funny version. So some ways to not, because batteries are like, they're probably like the most dangerous aspect of the whole project, and so like, we just want to make sure you don't do bad things with the batteries. So make sure to use the charger we give you to charge these batteries, and it's useful, like you can just plug it into a USB, so it's easy to charge and stuff like that. You want to never discharge below 3 volts, which, yeah, so you never want to do that. You can measure it yourself, and I mean, that's like probably the recommendation, but as long as you charge consistently, you should be fine with that. Just don't never charge them is the way to go. Then, yeah, if they become puffy or abnormal or start leaking anything, then you should definitely tell us, because that's bad, and your battery's probably like gonna explode or something. Well, probably not actually. But yeah, I mean, also some other common sense things: don't put it near like, don't put it near hot sources or heat sources. Don't put it in water or something like that. And you should be pretty much fine. All right, now back to my goat.
All right, now we're gonna be talking about voltage regulators. So voltage regulators, they're electronic components, as you can see on the right. And what they essentially do is they control the battery's output to maintain a constant voltage, regardless of like input voltage or load conditions. Okay. So why do we need voltage regulators? Well, in our Micromouse, our battery supplies power or voltage to our microcontroller unit or MCU. But the thing is, the voltage that we're getting from the battery operates at a much higher level voltage than we actually want. Because the MCU can only tolerate like a certain voltage level. So what we need to do is use a voltage regulator to limit that voltage. And you can see here in this image where it's like above is like the battery, the voltage the battery supplying to the MCU. But the thing is, like we want it to be at this level for it to be acceptable. So the voltage regulator essentially like limits that voltage. And another reason why we need a voltage regulator is that it keeps the power source. It basically keeps a constant power source so that the microcontroller unit can be stable. Otherwise, like if you don't and you were to turn on the motor, a slight voltage drop would occur, and this could cause your MCU to shut off or restart because it doesn't have like the necessary power to stay on. So the voltage regulator essentially prevents that. And like here you can see that there's like fluctuations, and then afterwards, after you use the voltage regulator, voltage is then constant, and it's lower too to make it acceptable for the MCU. The type of voltage regulators that we'll be using for our Micromouse is called a linear voltage regulator, and it behaves like a variable resistor. So depending on the voltage that we get, the resistance increases or decreases depending on it. This is the circuit diagram for a voltage regulator. You guys do not know, you guys don't need to know this information. It's just like if you're curious about it. But if I'm like saying a bunch of words that you guys don't understand, you guys will learn about it in like future classes. But yeah, we have an op amp that adjusts current through this pass element, and essentially it keeps V out constant. And what you can think of this is essentially it just burns off excess voltage. Don't worry, you don't have to understand this, it's just kind of interesting. And for the voltage regulator that we actually use for our wrap discorder, it's going to be a through-hole component, which is like this. So there's going to be two types of components that you guys are going to be working with. So there's through-hole component and SMD components, or surface mount device. And what this allows you to do is basically like just different ways of soldering it, right? So through-hole, as you can see here, there's like kind of like 3 legs. So how this looks like on a circuit board is there's going to be 3 holes corresponding to these 3 legs, and you just put the legs in the hole, and then you solder it on the other side so that it stays in place. Whereas like surface mount, you just like kind of slap it on the on the surface, and you solder around it. It'll make more sense once you guys actually start doing it. But the voltage regulator that we use is 3.3 volts and has a 800 milliamp output current. And then the microcontroller unit we have, it's called a nucleo. So we might refer to it as a nucleo, and it has its own voltage regulators, but the thing is we're not using them. So this is why we need this. And this is kind of like the finished circuit diagram of our voltage regulator. So the voltage regulator that we're using, it's called an LD117. And basically, so it's here, right? And then as you see, there's a capacitor. If you don't know what this is a capacitor, but it's connected in the front and it's connected in the back. And the purpose of this is to basically just smoothen out the voltage input and the voltage output out of the voltage regulators. So this means that like, hey, if I get a voltage spike when I'm trying to input into the voltage regulator, it'll kind of smoothen it out. And what this capacitor does, it stores that energy. And then say there's a voltage drop and I want to increase the voltage again, I want to send back that energy through this capacitor, so the capacitor would give off energy. And the reason why we still need a voltage regulator even though we smooth out these voltage is because that a voltage spike is still like, even after it gets smoothed out, it's still a voltage spike. It needs to be corrected by our voltage regulator. And same thing like our voltage drop, even though it'll be smoothened out by our capacitor, it's still a voltage drop and it'll be fixed by our voltage regulator.
All right. Yeah. And also, you'll make that schematic for your first like assignment or something. So maybe that's your first one, which I'll release after this, by the way. Okay. Oh wait. Now I'm gonna go over some of the software that we're gonna be using. Here's some funny pictures of professors at the school. All right. So for development, we're gonna be using the STM32 Cube IDE. So like on the Nucleo, and also probably what you'll be using for your actual Micromouse is a STM32 microcontroller, and so like this is their designated development environment. And so it's Eclipse-based programming suite, which is not like that important. Basically, it's just like a C and C++ development environment. It's a lot. If you ever use like Arduino IDE, it's definitely a lot more powerful, and also I guess like, well, I don't want to scare you and say complicated, but there's more parts than the Arduino IDE, and we're going to be programming in C. Then for designing your schematics and PCBs, we're going to be using KiCad, I think is how you say it.
That's right.
Yeah. And also we just this year switched to this, and so it's very possible that I was gonna say there might be mistakes in the assignments, but probably not.
No.
Probably not. But like, there's definitely you should ask if anything. Like, so don't think like I'm infallible or anything like that. Like I just made all these this summer and stuff, and they should be pretty good because like the old schematics were well documented. But just ask if anything if you're like, why does this work or something. All right. Was that it, or did I skip
Yeah.
something?
No, that's basically
All
it.
right.
It's a really short lecture. You guys have any questions? No. Okay.
Damn.
You like that?
Yeah. All right, let's see. All right, apparently we have a live demo.
Do you want to hear? I mean, okay.
We'll try. Oh shit.
Now, do you want to show these? Do you guys want to see a live demo?
Is there a video?
Nah.
No, that probably would have been better, but here, wait.
You could take
How did you even move this?
video of it.
I don't know. Wait, do you want me to hear it and do you see it or?
All right, no live demo.
Okay, no, okay.
Okay.
Find the very tacky video.
The
Versace video?
Yeah, just find it.
I don't even know if it'll work on this cardboard surface.
Okay.
Oh,
This is for random.
Yes, he already broke.
Okay. Here, but if you guys want to see a live demo in the future, just like come up, talk to us. We'll show you.
Yeah,
It's
yeah.
cool. It works.
And we have a better maze in the actual lab.
Yeah,
Oh, actually, I guess I could show you in the lab.
Yeah, okay, wait. So after this, we have a team formation social. So all of you guys will be put in like teams of 2 to 3, like we said. And we have a social after this dedicated to that. So like, it's a great way to meet other people and like form your teams. We'll send out a form where you can basically register for your team there. And if you can't find people, we'll just put people for you. So yeah. And then, okay, before we end though, these are the assignments that we're gonna be dropping. Don't worry, these are like due like 3 weeks from now. Like you guys have plenty of time. But oh wait, you get top off.
This is not 3 weeks from now.
It's like top off.
That's like a week and like 5 days or
That's
something.
like
Or what day is it today?
It's the 15th.
Yeah, that's a weekend. Wait, no.
We can find it.
Yeah, we can
Well,
find.
that's good
Weekend,
enough.
4 days.
Yeah, you'll be fine though, but like, don't be lying though.
Okay, I find you want to talk about this?
Yeah.
Okay.
What did you say?
Wait, you talk about this.
Oh, yeah. I mean, this is what you're going to be doing in the assignment. I'm going to release them after. You won't be able to start the A assignment until we assign you your team, because that requires you actually doing work on the rat kit that we give you. And so, don't worry about that one until you have a team. And then B though is individual and you can do it, and it shouldn't be that hard.
Yeah, and then so like the B assignments, they're gonna be more like soft. It's just gonna be like probably like schematic design, whereas like the A assignments, actually it'll be software too, but it'll be like hardware too.
Well, yeah, it's like it's making your rat and also like programming your rat a little bit. Actually, I think do these ones well, because you'll actually use these ones for your actual mouse, your Micromouse. So do them well.
So we're gonna send out like explicit directions of these assignments. Don't worry, you just have to follow them. It's like Legos. Just follow the
Yeah.
instructions. Follow what it says. You'll do fine. But assignment B, what you should get out of it is basically this circuit diagram. And like I was talking about before, this is the voltage regulator, and this is like what goes into it. And then for the 1A assignment, that'll introduce you to the software programming of how you program your rat, and like, so this is Cube IDE, and it'll introduce you to that, and then you should write your first program. And then you'll also be soldering on components, like through hole, like the holes I was talking about. And then, okay, I guess it's due 10/26, so you guys got time. And then the forms for the teams, we'll release them today, and then you guys just have to fill one out per team. And then we'll send out all the teams by like Friday.
Sure, sounds fine.
Yeah, and then as soon as like Monday, once you guys get your deposit in and your lab safety in, you guys can start working on it. Just come to the lab and it'll be good.
And then, oh wait, damn, I forgot this.
Okay.
All right, I don't know.
Okay, and then reminders. So please do your safety trainings. Like our email has like the information for it. It's just 4 safety trainings, and then that's due next Monday. And then please join us for our second lecture. Don't worry, it'll be less packed. We'll get a good room, and that'll be next Tuesday. And then our first work session. This is where we'll be there to help you guys, and it just gives you time to work on Micromouse. So you guys could like talk with other teams, do your work, and if you guys need help, we'll be there too. But just gives you time to work with us, and that'll be next Thursday. Yes.
Will the lectures always be on Tuesday at 6?
Yes.
For the most part, they'll be on Tuesdays, but like we're trying to do 6:30. But we're also like recording these, so and we'll post the slides, so don't feel bad if you miss any of them. Yeah.
The work session,
What time? This will probably. I think it's also at 6 or 6:30.
if I have class, Thursday and Friday.
Well,
Oh
you-
wait, don't.
These are like, I don't know how to explain it. Like these are just like to motivate you to come and do work.
Exactly.
But you could do work at any time.
Yeah,
And
like-
you can just be like, hey team, let's go work. And then if they're not bums, they'll be like, yeah, okay, let's do work. Yeah, it should be fine without it. We can also probably do it at like 7 if that's better for more people, which it probably is.
Also, these work sessions are really long too, like probably like 2 hours or more. So we'll be there for a long time if your class does end, and we'll try to like bring food, bring like cool stuff for you guys. And then another thing is the IEEE lab hours. Me and Michael were there on Fridays, like in the afternoon from like 12 to 3. So
12 to 4,
like
I think.
12 to 4. But then you guys could come in there and ask us questions then too. But otherwise than that, like in the IEEE lab, there's plenty of officers who've done this project before, and they're like all willing to help you guys. So you guys can come in anytime. Yeah, but in the website, you guys can just see, or the Discord, you guys can see like which officers are available at which times.
And hopefully we get those name tags so you actually know who an officer is.
Okay. Yeah.
All right.
Okay. Discord housekeeping. Make sure that you are getting our announcements in the Micromouse channels. There you go.
Yeah. Actually, some of you guys have already sent me friend requests and I've denied them because I didn't read them before. I didn't know I was supposed to accept them. And so like if you send me again, I'll accept it. Because I'm trying not to like get a super long friends list, but I guess I'll do it, you know, it's all right. Yeah, and focus on that Micromouse announcements channel.
Yeah.
I'll be posting some crazy stuff. If you like are one of those people and you hate having Discord notifications on because like you always get them, just mute everything else and unmute this one. Say like only at mentions and you'll get notifications for that. And I'll at you with important information.
Okay. Okay, and then getting your rack kits. So how do you start? We're gonna be giving you guys once we finalize the teams, as soon as Monday, you guys can come in, and then we'll give you like a team number. Like our teams range from like 1 to probably like what, 27.
26, 27.
Yeah, we're taking a lot, but we'll give you guys rack kits with like the PCBs and all the parts that you guys need to complete these assignments. And you guys should just come in, but make sure you guys complete the lab safety trainings and the deposit. And I think is that it?
Well, you'll find out when you press
Okay.
next.
Okay.
All right.
Okay, thank you. Oh wait, hold on. And then after this, we have team formation social. Like right after this, we're gonna be going to the IEEE lab, and we have pizza. So
Yeah. Oh shit, what time is it?
it's 6:30. We're gonna make it. Oh, we're taking them to the IEEE lab. So we're gonna be going to the IEEE lab, and then you guys can just talk, and like if you don't have a team, you guys can meet other people. But thank you guys all for coming.
Sorry.